Let us now see the parts of a travelling microscope and its operation and least count of the travelling microscope. First, let us see what are the parts. You can see that you have an objective and an eyepiece for viewing the readings. You can rotate this by loosening the screw given here or the knob given here and set it either in the vertical position or in the horizontal position. Horizontal, vertical. This depends on the measurements you are going to make. We also have a rack and pinion type of arrangement for adjusting the focus of the microscope. See, this is the rack and pinion arrangement of the microscope, which you can use for adjusting the focus. We also have two scales in the microscope, that is the horizontal scale and the vertical scale. So in the horizontal scale, you can see that you have a main screw or a locking screw, which when loosened makes the travelling microscope move freely in the horizontal direction. When this screw is tightened, this fine adjustment which you see here will work. You can see as I rotate this, you can see that this is moving. You can see this is actually moving in very small fine steps. Then this main screw is loosened and you rotate this fine adjustment. This scale will not move. You may face situations where after tightening the main screw and using the fine adjustment for making measurements and noting down readings, this screw may be fully used up and you will not be able to move in small fine steps any further. At this stage, what you should do is loosen the main screw, unwind the lock fine adjustment to its full usage, anyway when you do this there won't be any movements here, so you will be in the same reading where you left off. So you need not worry that when you actually keep rotating this fine adjustment, this may move. So once you have done this, lock the locking screw and start reusing the fine adjustment from the place you have left off. I will repeat this part because this is a common problem encountered by everybody, and even after mentioning, students face this trouble. So I'll repeat while making measurements. If you are rotating the fine adjustment and still the reading is not moving, then what you have to do is you have to loosen the fine force adjustment or the locking screw and then wind or unwind the fine adjustment to its initial position. You need not worry, the reading will not move because we have relieved the contact of the 4 screw from the fine adjustment. So after completely winding or unwinding, whichever the case may be, tighten the main screw and start taking the reading from where you have left off. The reading will be exactly at the same position where you were, it will not change. So whatever holds good for the horizontal scale, the same thing holds good for the vertical scale also. Now where is the main screw for the vertical scale? Let us see that now. This is the main screw of the vertical scale, and when you are using this, generally the position of the microscope will be in the horizontal position. So this is the position when you use the vertical scale. So now this is the main screw. You can see when I loosen this, there is free movement of the scale. Once I tighten this, it will not move freely. Only this fine adjustment should be used. So this will move the reading in small fine steps. Again, as I told for the horizontal scale, if this is completely used up, loosen the main screw, hold the scale with one hand so that it does not fall, and then wind or unwind the fine screw. Then tighten the main or locking screw of the vertical scale, then start using the fine adjustment screw. This is so because there is a limit for usage of the fine adjustment screw. Once we cross that limit, the reading will not move. That is why we have to loosen the main screw and wind or unwind the fine adjustment, then tighten the main adjustment again, then start using the fine adjustment screw. Let us now see how to calculate the least count of a travelling microscope. We will take the horizontal scale for this and take some reading on the main scale. So this is the main scale, and here you can see vernier scale. So first we will see the main scale and calculate what is one main scale division equal to. So we will take the example of the readings between 11 and 12. So when you take between 11 and 12, you can see, count the number of divisions from 11 to 12, you will find there are 20 divisions, and from 11 to 12 the value is 1 centimeters. So what does it mean? 20 divisions on the main scale is equal to 1 centimeter. So we have 1 centimeter is equal to 20 divisions, which means one division will be 1 by 20th of a centimeter, which means value of one main scale division is 1 by 20th of a centimeter, which means it is 0.05 centimeter. Now you can see that there are 50 divisions on the vernier scale, that is 10, 20, 30, 40, 50. You don't worry about what is marked as 0.1, 0.2, 0.3, etc. You should not consider these 0.1, 0.2, etc. when you take the readings. There are 50 divisions on the vernier scale. So the total number of divisions on the vernier is equal to 50. So the least count is value of one main scale division divided by total number of divisions on the vernier. That means one main scale division here has been divided into 50 parts. So that is why we have the least count as one main scale division by total number of divisions on the vernier. And what is value of 1 MSD? 0.05 centimeters. So that divided by 50. And what will that yield? 0.001 centimeters. So the least count of a traveling microscope is 0.001 centimeters. Let us now see how we can record readings. This is the 0 of the vernier, and for the horizontal scale the readings increase from left to right. So you can see 11, 12, 13, 14, etc. And each division on the main scale is 0.05 centimeters. That is, you have 11 means next one will be 11.05, then 11.1, 11.15, 11.2, 11.25 and so on. The center one here is 11.5, etc. Now let us see what this reading is. For seeing the reading, we must actually see what is to the left of the 0 of the vernier, and in this case it is 10.75. You can see 10.5, then 10.6, 10.7, and to the left of the vernier we have 10.75 as the main scale reading. And the vernier, in the vernier, if you see, the 26th reading coincides. That is what we have recorded. As I told earlier, don't see all this 0.1, 0.2, etc. It is only the divisions you have to see. That is 10, 20, 30, 40, 50, etc. So whichever division coincides, we have to note down. And now we have noted down that as the 26th division. Now we will see where we will record the readings we have taken. Usually for recording any traveling microscope readings, you will have a tabulation in the format shown here. On top of the tabulation, you should always write least count, that is LC equal to 0.001 centimeters. You will have a serial number in which, depending on the experiment, it may be the order of the fringe, or it may also be the load what you are going to add, as in the case of Young's modulus experiment. In the next column, you will have main scale reading, which you are going to record in centimeters. So when we convert later on, it will be into 10 power minus 2 meters. Then a column for vernier scale coincidence, which will be in divisions, and then the total reading which we will have to compute, and that will be main scale reading plus vernier scale coincidence into least count, which will be in centimeters, and on conversion to meters you will get into 10 power minus 2 meters. In our case, I have shown you a sample reading in which main scale reading was 10.75 and vernier scale coincidence was 26. So what will be the total reading now? Let us see how to do that. Obviously the reading is 10.776, and how did we get that? We will see now. It is going to be 10.75 on the main scale, and vernier scale coincidence into least count will be 26 into 0.001, which is 0.026. So when you add both, you get 10.776. That is the total reading. In this fashion, we can record how many ever readings you want, adopting the procedure of rotating only the fine adjustment as I specified earlier. Similarly, we can see vertical scale readings also can be recorded, but the readings here, you must remember, increase upwards. You can see 50 divisions on the vernier on the left side. On the right side you have the main scale increasing upwards in a similar fashion, again increasing in steps of 0.05 centimeters. So before the 0 of the vernier, that is below, in this case whatever main scale is there, below the 0 of the vernier you have to record, and what are the divisions on the vernier which coincides with the, what is the division on the vernier which coincides with some main scale reading, we have to record in a similar tabulation.